classical physics. And my friend Arun Asthana, who has already taken one of the classes for modern physics. So he'll be covering the modern physics section, and I'll be covering the classical physics, or as we say it, Newtonian physics. Okay. Okay. So let us start. So firstly, let me ask a question to all of you. Like, what is physics? I know that Aryan has already covered this aspect, but that was with in regard to modern physics. But this is Newtonian physics. So here we are taking up some new concepts, and then we'll try to analyze that what is physics. So anyone wants to answer that? What do they know about physics? And after that, I'll answer. Any concept from the previous class which you have embedded in your mind? Okay. Okay, I'll explain. So firstly, it is the answer to the questions how and why. Okay. Q or kaise, in simple terms, in lucid language. So let us take an example. As you can see below is a man who is walking. Okay. Now, first question which arises in all of our minds, which should arise, is how is he able to move forward? Okay. So in lucid language, we may say that he is using his voluntary muscles to move forward. Okay, that is fine. But how a physicist sees it, like we should you know see this in that manner also. We should wear the glasses of a physicist and then analyze the situation. That how is he able to move forward? So okay, let's get the answer to this question. So he is exerting a force onto the ground. Okay, we're not taking the name of the force. He is just exerting an unknown force onto the ground, which is helping him move forward. एक फोर्स है जो कि वो इंसान ग्राउंड पे exert कर रहा है, and due to that force he is able to propagate further. Second question that arises is why is the man not falling? Like if he is walking, then why is he able to walk? He's not falling. Anyone knows the answer to this question? Why is the man not falling and he's able to walk properly? Anyone? Okay, if anyone knows, then please. Okay, friction. Yeah. Okay, fine. Okay. So yeah, correct answer, friction. Okay. And why do our shoes wear and tear? What is the answer to this question? Due to balancing of action reaction. Okay, that is fine. Good to go with. Okay, but the answer to this question, to be very precise, is friction only. So we have named this force friction for now, but we will not deep dive into the concept. We will be covering this later. So okay, the first answer is that he is exerting a force. वो जमीन पे एक force लगा रहा है, and due to that force, he is able to move forward. And the earth, the ground on which he is walking, that is also exerting a force onto the feet of the person. Okay, friction always applies to the acts opposite to the force. Okay, so for example, if he is putting his force, this is the force which he is exerting on the ground, this force, and this is friction which is opposing his motion. Due to this, we feel we have wear and tear in our shoes. Okay, this is due to the force of friction, and due to friction only he is able to walk and he is not falling. Okay, are these three things clear to everyone? Please reply in the chat box and then we'll move further. If not clear, then I also have a stylus with me and I can use the whiteboard to make it more easier for you. Okay. Okay. Now let us take one more example. As you can see, the man is pushing the box. Okay. And there, just don't get confused by the names, that what is a free body diagram and what are these terms. We will discuss these later, but for now let me explain that what is a free body diagram. Free body diagram basically shows all the forces that are acting upon a system. For example, if we take the system to be this box, okay, this box is the system in consideration. So free body diagram is basically the forces which are acting onto the box. So this is the free body diagram of this box. Now here is this box, okay, the free body diagram of this box. So let us analyze that what are the forces acting upon the box. So firstly, as you can see here, it is written F applied. Okay, APP means F applied, the force which the man is applying on the box. So yeah, this force is being applying on the box on in this side. Now the gravity and normal, for now you can ignore these two forces. Just take in consideration these two forces, the applied force and the force of friction. Okay, is that fine? The force of friction always acts in the opposite to the applied force. So here we are having the applied force, and then there is the force of friction. As we have seen in this case also, the man is exerting the force on the ground firstly, and then the friction is acting upon the shoes of the man, or the body of the man, as we say. So are these two examples clear, or do I need to define them more? Okay. If you have any doubts, just write it, collate in the chat box, and I'll be taking up the doubts at the end of the session, or maybe in the meanwhile also I can take the doubts. Okay. Now, so let us answer in lucid terms. We have already answered that it is the answer to why and how. The physics is answer to why and how. Now let us see how we can define it more precisely. So physics is nothing but applied mathematics which governs the laws and principles of the universe and help us predict the future. We'll be taking up definitions one by one. So this is the first definition. Okay. So suppose let us understand this definition through the first example. Okay. Let us come back to this example once again. Now suppose what happens is the man is walking and suddenly he sees that there's a manhole ahead. Okay, his reaction time is somewhere around 2 to 3 seconds. Now he sees a manhole, and suppose he is walking at the speed of 2 kilometers per hour or 1 kilometer per hour, whatever it is. Now he sees a manhole ahead. So what would be your reaction if you are walking and you suddenly see a manhole on the road? What would be your reaction? Natural reaction that you would stop. You would try to stop yourself so that you don't fall into the manhole. Okay, or if your speed is too much, then might be a possibility that you fall into the manhole, or you might avoid the accident as well. So this is what it is. So for example, the manhole is say 5 meters ahead and the man is walking at 2 kilometers per hour. Then how do we deduce that whether the man will fall into the manhole or he might avoid the accident? So for that purpose, we need mathematics. Physics is applied mathematics which governs the laws and principles of the universe and help us predict the future. Keep a note of this, that help us predict the future. This is how the man's future would be decided through mathematics, that whether he would be able to avoid the accident or he will fall into the manhole. That is what happens in the accidents. For example, you are driving a car and then you see a child in front of you. So your reaction is to apply the brakes. Your car deaccelerates and finally you stops. But sometimes the speeds are so much that even the cars are not able to stop. So you might meet with an accident. So the use of mathematics in physics is basically to calculate that what might be the future. So in this case, the future of the man that would be decided. We are not going into the numerical portion because that is not required. And when it will be required, I'll definitely solve one or two numericals to help you understand this concept better. So this is basically that it is helping us predict the future of the man, that whether he would avoid the accident or he would fall into the manhole. Second definition says physics is the knowledge of nature. Okay. This is also nothing different, but yeah, kind of same, that it governs the laws and principles of the universe. So yeah, physics is also called as the knowledge of nature because it talks about all the principles which are going on in the universe. Now, or measurement of physical quantities. This is a very lucid term. Physical quantities, for example, time, okay, length. These are all physical quantities, basic physical quantities. So measurement of these quantities is known as physics. Okay. So up till now, it is all clear, or shall I explain it once more? Or anyone wants to add anything? Okay. Okay, Smita, we would not deep dive into those concepts, but like other students might get confused what is deacceleration. But yeah, in the chapters, we would be discussing it in much more knowledge. Okay. Any other questions? Anyone else? Okay, but okay, so one question she has asked, so let me explain that what is deacceleration. So what happens is the negative acceleration. When you drive a car, you put your feet onto the accelerator and you raise your speeds, okay, from 10, 20, 30, 40, you go up to 60, 70, whatever you might go up to. But what happens when you put your feet on the brakes, when you apply the brakes, that is deacceleration. Okay, when your speed is coming down to zero, you were at 100 and now you see a child or a person standing in front of you and you have to apply the brakes. आपको brakes लगाने हैं. Okay, so when you put your feet on the brake, so from 100 you try to come to zero to avoid the accident. So that is deacceleration, that is negative of acceleration. Okay, Ismita, is that clear? Yes, Vivek. Yes. Okay, so type of friction. See, this is just an introductory chapter. There are many types of friction, so we would be discussing it. That for civil services, we are not to deep dive into those concepts, but I can explain you in the later chapters when we will be discussing in much more context. Okay. Yes, Smita. Okay, fine. So, for example, now, okay, yeah. So one more question. One not question, just an example to make your concepts more clear regarding the topic. So can you see this graph clearly, or do I need to expand it more? Is it fine now? Okay. So here's a little bit of mathematics, a bit of mathematics. So let me explain you this through a graph. So on the y-axis, okay, the vertical axis, it's given distance 10, 20, 30, 40, 50, etc. And on the x-axis, it's given the time, okay, 5, 10, 15, 20, 25, etc. So what is this line going through the center or the origin? What is this line? What does this line tells us? Anyone can answer? Yes, exactly. Yes, Vivek, speed. Exactly. So through this graph, I'm like, I want to show you that how is mathematics applied in physics. For that purpose, I've kept this graph. So now the slope, okay, you can see that this line is tilted at an at an angle to the y-axis, to the x-axis. So the slope of this line, slope matlab, you can say that, for example, this is a slope, right? You have seen rides, swings. So this is how rides are, right? Slope. So this is also a kind of a slope we have to find out for this line. The slope of this line will give us the speed. If someone asks you that for 20, distance 20 and time 10, what is the speed? You can find it out easily by finding out the slope of this graph. So this is how mathematics is applied to find out the conclusions for physics. Is that clear, or shall I explain it again? Or anyone else wants to add anything, then he or she can. Okay, I'm assuming that this is fine. Okay, okay. So, okay. So I've made this question. So I want all of you, not all of you, but if anyone knows the concepts and wants to answer this question, then he or she may answer this question. I made this question. I just want to see that how much you like the prerequisites. Do you have that or not, or I have to tell that basically? And even if you don't know, that's totally fine. I'll be giving a concept through this question. So that's why I'm asking this. Okay, Vivek has said A. Others also, you may please try. There's nothing like no, what would judge you? Just try to answer this one. Okay, so the majority says the option is A. Okay, please explain the question. Okay, Smita is asking the question. Okay, B, B, C. Okay, first let me explain the question and then we'll move on to the answer. And who has said C? Jagyasa, and one more person said C, right? No, okay, okay, one, okay. So the question basically is assertion. Firstly, we are asserting, we are saying a statement, we're declaring a statement that man is walking, suddenly slips and falls. Okay, this we have asserted that this has happened. Reason for that assertion that I have given is friction became zero, leading the man to fall. Okay, have you got it, Smita, or do I need to explain it more? Fine. Okay, it follows the third law of motion. Okay. Okay, so the correct option is option C. Assertion is true, but not the reason. But in the first slide itself, I said that why is the man not falling, and I gave you the reason that due to friction he is not falling. And now I am contradicting myself by saying that option C is correct. That means the reason is not correct. Friction became zero. So how can you justify this? That in the first slide I did contradict myself by stating this reason. Option C is correct. That is for sure. Exactly. Exactly. Friction can never be zero. Even in the most ideal conditions, friction can never be zero. It can be reduced. It can tend to zero, but can never be zero. Okay. The value lies between 0 to 1, and in some cases it might exceed 1 as well, but it can never become zero. So if anyone says that a man is falling somewhere and the friction became zero, that is impossible. Friction can never be zero. Okay, it can reduce till zero, intending to zero but not zero, because that is not practically possible. If friction becomes zero, then we might not able be to sit also, and we might not able be to stand also. Okay, so yes, option C is correct. So just remember this concept that friction can never be zero. Now, so as I'm giving introduction, so if you have any doubts that what that one person asked that what kinds of friction, so we will definitely go into details when we will be covering the chapters, because it's just an introduction. So let us keep with the stick to the basic knowledge, okay? And let's not deep dive right now because others might get find it difficult. So yeah, uh, is this clear that why is this happening? And if someone is asking this question that why friction cannot become zero, then firstly, it is not practically possible. The scientists have already deduced it. But if you still want a reason, then just suppose this that until and unless there is something, the anomalies of two objects, until and unless they haven't been locked, okay, until and unless they haven't been locked, you can't say that you can't say in general that friction is zero because there is always two objects. For consider two objects, two pens for example. If these are two objects, then there is some irregularities on the surface of both of the objects which get locked. ये दोनों ऐसे locked हो जाते हैं. We can't see those irregularities because those are very small atomic level irregularities. Okay, we can't see those irregularities, but these gets locked. Due to that, friction is reduced, and every object, every surface has some irregularities. So yeah, friction can never be zero. Okay, so now sorry, we will first look that what are we going to study, okay, before starting the chapters. So firstly, motion, measurement, and time. So for example, I've given this example: a bus moving is known as motion. So how can a bus moving is can be called in motion? If in a reference frame, or okay, just leave it, not reference frame. Let's not get to the typical terms. For example, if a person is changing his position, for example, if I'm sitting here and the next moment I go to the other room, I am changing my position. Okay, that means I am in motion. Now, secondly, measurement that we all know that measuring quantities or measuring things is known as measurement. If we are measuring our height, that is also measurement. Measuring the length of our bed sheet, that is also measurement. Measuring the length of our clothes, that is also measurement. Now, what is time? So the period during which an action exists is known as time, and time is a physical quantity. In physics, we deal it as such. And apart from that, we can have one more definition, that progression from past into present into future, that is also time. Those are some basic definitions of the concepts which we are going to study in detail. Now, secondly, we are going to study force and pressure. Okay. So now anything which can influence the motion of an object is known as force. So now let us go back to the first example itself. Uh, do you see this box? Okay. So what is this man doing? He's pushing the box. So what do you think? The box will move or not? If the conditions are ideal, friction can be taken negligible. If the friction is taken negligible, will the box move or not? It will move because we are taking friction to be negligible. It will definitely move. So now what is causing the box to move? Definitely some force is causing the box to move. So can we not say that force is something which influences the motion of an object? We can deduce from this example itself that the applied force caused the box to move. That means force can change the motion of an object. It does not only mean that it can bring an object to motion, it can even stop an object. For example, if something is coming towards you, moving towards you, then you do have to apply force with your hands. Or if it's a small object, then you have to do have to apply force with your hands to stop that object. So it can bring an object to motion and even stop that object in motion. Okay. Okay. Once again, I am requesting all of you. That is fine. F is equals to ma. Okay. But let's not dive into these topics right now. We would be definitely deducing these statements, these equations in the later chapters. Okay, so example football also. When you kick a football, it starts to move. When you press it with your feet, if the moving football is coming towards you, you press it with your feet, the ball stops. Now, where is, oh, sorry, oh, that was example of friction also, but that is applicable to football as well. So now, what is pressure? Just a second, guys. So, pressure is force per unit area. Okay, force acting upon an area is known as pressure. Now, what example can we take for this? For example, uh, the nails which we, knock into the walls with the help of a hammer, the nails which we put into the walls with the help of a hammer. So what happens is those have very small surface area, and when we put some force with our hands, that gets embedded inside the wall. That is pressure. The unit area is small. The area of the nail, that is really small, right? So when we act with some force on the nail, it gets embedded inside the wall. So that is pressure. Pressure is equals to force upon area. Lesser the area, more the pressure. That we would be discussing in the later chapters. But for now, this is the only this is the example which I'm giving to you. If you want any more examples, I can give it to you as well. Elephant in circus. Uh, could you please like elaborate this one, Vivek? Okay, so moving on. Friction that we have already discussed with too many examples. Three examples I've taken, two examples to discuss what is friction. If you still have any doubt in friction, then please let me know. Okay, just one more example. For example, football. When we kick a football, what happens? After a certain time, the footballs comes to rest. When we kick a football, it travels some distance, say 5 meters, it traveled, and after some time, it rolls and rolls, and then comes to rest. So what is happening? There is some opposing force, right, which is stopping the football. That opposing force is friction, acting in the opposite direction to the applied force. Is it clear through all the examples? Please type in the chat box, then we'll move further. Okay, so next, pardon, please. Okay, if any doubts, then you can ask. I'm ready to resolve those doubts. So gravitation. So the central force acting between bodies is gravitation. Okay, not gravity. This is, we are talking about gravitation. This is the force acting between bodies, which we would be discussing later in quite depth. So the question here arises is that uh, the force acting between two bodies, and us, our physicists have said that this is the force which act between every two bodies on the universe. So like, do we all attract each other? For example, if I meet you somewhere, say the Pathjyoti IA Center in Allahabad, and if I meet you, so does that mean I'll come and cling into you? Will that happen? If we are attracting each other, does that mean automatically we'll come and stick into each other or cling together? Will that happen? Yes or no? Or any reasons you have for that? Please explain. No, Vivek, how would like, okay, if you meet me today, then what will happen? We'll come and cling together. Is that possible? No, right? That won't happen. So, firstly, this law is applicable for heavy bodies. Okay, this the gravitation, the formula which we are going to study, which we would be deriving and then studying, is applicable only for heavy bodies as well as point masses. Okay, that is applicable for say sun and the earth. That is applicable for sun and the earth. Why? Point masses, firstly, point masses does not mean that anything which is infinite small or very pointed, not that. Point small is a relative word. For example, the sun and the earth, those are all point masses. Now you might ask that how are the point masses? Yeah, like they are such big and such visible to us, that how can they be point masses, right? The question might arise in the mind that how can they be point masses? The thing is, the distance between sun and the earth is so huge that they both, with respect to each other, are point masses. Okay, and heavy bodies, obviously they are heavy bodies. The sun is like heavy, the earth is heavy, so they are heavy bodies. So the question here is that whether there is a force of gravitation between these two bodies. Yes, of course, there is a force of gravitation, and that value we would be calculating in the later classes. But for here, for now, the question is, do we all attract each other? No, we are not attracting each other. The reason being the gravitational constant is so small value. Like for example, for example, say my weight is 70 and Vivek's weight is 80 kgs. Okay, 10 to the power 2 हो गया, दो ही zero आए केवल. The value of gravitational constant is around 6.67 into 10 to the power minus 11. Don't get confused. It's just a constant. We would be getting to learn about this constant later in the chapters. So 10 to the power minus 11 into 10 to the power 2, that would still make up to 10 to the power 9, right? That is very small value. Are you getting it? So even if there is a force, there is definitely a force. For example, if me and Vivek, we are meeting today at the Pathjyoti Eye Center, then definitely there is a force. There is a force between both of us or between any of us. Okay, there is a force, equal and opposite force. But the value is more small that we have to neglect it. There is a force, but that is neglected because that is more small force. Okay. Now next, work and energy. So work is the product of force and displacement. So let's not go by this definition. I tried to simplify it more. So I have one example for you. So our respected mentors, they all prepare these lectures of history, geography, and all these subjects throughout, and they work so hard for us. So are they really working for us? Like if talking of in general terms, so they are preparing these lectures, or even I prepared this lecture. So like I am, have I done some work? Did I? Can you answer this? Why is the chat box not visible? Yeah, anyone? Okay. Rest of the people, please reply. I'm not going to pinpoint anyone. So yeah, please. Okay, no sir, no sir. Okay. मतलब कुछ नहीं काम किया है हम लोगों ने, right? Not in physical terms. In terms of physics, no sir. Exactly. Exactly. Because be it me, be it our respected Shaurya sir, Oja sir, or respected Iti ma'am, they are preparing these lectures throughout. I totally agree. But are they displacing from this position? Are they moving from this position while preparing those lectures? For example, if I am teaching you right here, so what I am doing, am I moving around and teaching? मैं ऐसा पूरे घर में घूम के तो right, I'm not teaching you, right? I am just sitting at a place and imparting some knowledge which I have gained. So in general terms, yes, I am working. Everyone is working. All our mentors are working. But in terms of physics, their work is zero. Work is zero because they are not moving. Displacement, for now, just understand displacement means distance, you can say, or movement. So they are not working, right? If they are not moving, the physics says कि भैया अगर आप नहीं चल रहे हो, you're not moving, आप डिस्टेंस नहीं कवर कर रहे हो, मतलब आपने कोई काम नहीं किया है. Okay. So in general terms, yes, we all are working, but in physical terms, in terms of physics, we are not working at all. So now, what is energy? Sorry, guys, I have a bad throat. So energy is the capacity to do work. So अब बात होगी कि energy क्या होती है? Okay. So energy is the capacity to do work in very lucid terms. Okay, just example like a coolie. Okay, yeah, we would discuss that example later. That why the work done by coolie. Okay, but what about a teacher who moves around and teach? Yeah, definitely. But see, Sejal, the thing is, for example, if that person or who is moving, for example, if the teacher is teaching, is on the one side of the board, and then he comes to this side of the board, then he go back to this side of the board, then his whole, and then again come back to this. So displacement, the total displacement would be still zero. Okay. But for example, if I started teaching from this side and then I moved 2 meters ahead in my room or to another room, then yes, I have covered some distance. Not like not in teaching I'm doing some work, but yes, I have covered some distance. Then definitely yes, I have done some work. If they have a beginning, exactly. If they have a beginning point and end point. Anyone else wants to add something? Okay. So, shall I move further? Is the concept of work clear for now? It's just a basic knowledge which I have told here. Angle of movement. Okay, we'll cover it. See, the whole purpose of this is to firstly get your fundamentals clear. Okay, because if you can't directly deep dive into the you if okay, you can't directly deep dive into the big concepts without you getting your fundamentals clear. Okay, so angle of movement and everything we would be covering, but not for now. Let us stick to the basics. So now what is energy? So yeah, for example, say energy is energy is nothing but the work done. Okay, in simple terms, if we say, for example, take a brick. Okay, and for example, if I hold this pen, I hold this stylus in my hand. I am having at this stylus at my desk. Okay, now I hold it to the height of around say whatever height this might be. Now, when I drop this stylus, so what do you think? My hand is kept below. Will it hurt me? Not that much, but yeah, it might hurt. But if I reduce the height, then it will not hurt at all. But now, further, if I extend the height more, say up to the height of my room, and then keep myself below it, then it will definitely hurt me. Because now what has happened is this has gained some energy. This has gained some energy that we call as potential energy, but just don't get confused that why what kind of energy this is and what kinds of energy there are. So this has gained some energy, okay, because it has done some work against the gravity. When I move this upward, considering g is equal to 9.8, when I move this upward, I am doing some work against gravity. So this has gained some energy. And now when it falls off, then it will hurt the person standing below. Okay. You can take the example of a brick also. If the brick is, for example, if I keep my hand here and keep the brick here, I let it drop, nothing would happen to me. But if I do the same thing by extending the height, I keep the brick there or the top of my roof, and then so I probably won't be taking the next class if I do so. Okay, so because I have already because the brick has gained energy, so now if it falls, then you know what will happen. Is that clear? Please reply in the chat box. Smita, any doubts? Okay, fine. So law of conservation of energy that we would be discussing. So next is, so yes, we would be starting from very basics, measurement and motion. So it's already 2:40. I'll just give you a brief about the chapter, or I'll just complete this one slide. So, or we can, okay, just a second. We can take up doubts. Okay, we'll start this in the next class. It's already 2:40 and it's too much. If any doubts, then please, from this till this, please stick to these, because please do not deep dive into the big concepts. Please stick to these slides which I have shown you for now. And anyone has to add anything, then please add. Anyone wants to add or ask any question? Uh, yeah, from 2 to 3, but I guess sir has asked to wrap it till 40 to 50 minutes. So that's why I'm not starting it. We can start it from the next class. Okay. How can we fly? Okay, Aryan. I'll call you and explain this on a call, that how can we fly. Smita, I anticipate that you must also having this question, that how can we fly? Okay, fine. Any other questions? Yeah, Jigyasa, it's fine. And actually, from 2 to 3, that schedule is from 2 to 3, but sir has told us to wrap it up till 2:40 to 50. So that's why I'm not starting, because it's already 2:45. So next time we'll start the chapter. Answer, Vivek, Aryan, Vivek has answered your question, sir, in space. So now probably I won't call you. If the normal force that Earth exerts on our body, no, how would we? Those forces are balanced out, right? The, just because of them, we are able to stand still on the ground. Whatever force we exert on the ground, that is the equal force ground exerts on us. So how can we fly? Those forces gets balanced out. Okay, exactly. Is sir there? Host, is sir there in the meeting? Hello. I guess sir is not here, right?